This is the second presentation of exploring similarity in solids. So what are similar solids? These are solids that have the same shape and different size. So all of the major side lengths, like height, length, width, radius, diameter, those will all correspond at a same scale factor. When we start to deal with surface area and volume, we tweak that scale factor a bit. We square for surface area the scale factor, and we cube the scale factor for volume. But similar solids are solids that have the same shape and different size. So we're just going to take a look at example problems today that deals with similarity, just to reinforce and solidify that conceptual knowledge for you. So let's take a look at some examples. So are these solids similar? So I have triangular pyramids, and I'm just going to check corresponding side lengths. So I'm going to start first with the smallest ones here, which is 6 for the one on the left, 8 for the one on the right, and that reduces to 3/4. Then I'm going to check the widths, I guess, here. This is 8, and that's 12, and that reduces not to 3/4, but actually to 2/3. Now, since I'm doing some work, I'm going to do the heights just for fun. This one is 16. I'm sorry, that one's 12, and this one's 16. And that corresponds at 3/4. So two sets of the three correspond at the same one number of 3/4. But this one here doesn't. This one corresponds at 2/3. So because these numbers don't match, and you don't have to do all three. Like you can just stop. If you have something that doesn't match right off the bat, and you're doing them in like corresponding like side lengths, like you're doing that correctly, then you can stop and just say that they're not similar. All right, let's take a look at another example. So I have some cones here. So I have the radius of one cone at 15 and a radius of the bigger cone at 25. And I'm going to check that ratio, and 15/25 reduces to 3/5. And now I'm going to do the heights. The height is 36 here, and the height here is 60. And 36/60 actually reduces to 3/5. So these, in this case, actually reduce to the same number, and that same number that they reduce to is my scale factor. So my scale factor is 3/5. All right. So let's take a look at how that scale factor gets tweaked when we deal with surface area and volume. So in this case, the solids have a scale factor of 4 to 7. So one side length here is 4 up here. This one's at 7. So the scale factor is going to be 4 to 7. And then if I'm going to take a look at the surface area, so that's the area around the solid, okay, I have to square the scale factor because area is in square units. So I'm going to have to square the scale factor. So 4 squared becomes 16, and 7 squared becomes 49. And then if I want to figure out the amount of stuff inside, or volume, then I'm going to need to cube the scale factor. So 4 cubed is going to be 64, and 7 cubed is going to be 343. So the scale factor for the volume of these two solids is actually corresponding at 64 over 343. So let's take a look at an actual example that has numbers. So I have two cylinders. I have a cylinder on the left with a radius of 2, a cylinder on the right with a radius of 8. So that corresponds at 2 to 8. And I'm going to reduce that right off the bat, and that's going to be 1 to 4. Okay. Then if I'm going to take a look at the surface area, that's the area around the figure, then I need to square the scale factor. So 1 squared is still 1, 4 squared is 16. So this one on the right actually has 16 times the amount of surface area around it. And then the volumes, I'm going to cube the scale factor. 1 cubed is still 1, and 4 cubed is actually 64. So believe it or not, the cylinder on the right has 64 times more volume than the cylinder on the left. To me, that's pretty wicked. Like, that's pretty amazing. Okay, so let's take a look at the volumes of these two similar solids. So volume is just area of the base times height, or base times height times width, whatever, or length times width times height, whatever you want to do to figure out the volumes of the solids. I know the dimensions on the solid on the top, the big one, so I can go 6 times 12 times 6, and that's going to give me a really big number. But I guess I did the ratios first, so I guess I'm going to have to do the ratios. Sorry, I overstepped my bounds. So I'm going to compare the only numbers I've got. So I have 6 for length here, and that corresponds with 4 the length here. So I'm going to take a ratio of these side lengths, 6 to 4, and reduce that to becomes 3/2. And then to take care of the volume, then I'm going to have to cube that scale factor. So 3 cubed is 27, and 2 cubed is 8. And now I can use that scale factor to figure out the volume of the small solid. So as I alluded to earlier, the volume of the big one is 6 times 12 times 6, or 6 times 6 times 12, in whichever case you want to do there. And I get 432 cubic units. So 432 cubic units here. And then I use that scale factor because the 432 deals with the solid on the right, or on the solid on the top, and the big solid. So when I set up my proportion, the big number also has to go on top. So my ratio becomes 27 over 8 equals 432 over x. And when I cross multiply, I get 27x equals 8 times 432. And then when I take those two numbers and multiply them and then divide by 27, I get 128 cubic units for the solid on the right, or the small solid. Okay, so I want to find the volume of the large cylinder. So that's got a radius of 6 feet, and the radius of the small cylinder is 3 feet. And I know the volume of the small cylinder, okay? So I need to figure out the scale factor first. So I'm dealing with a 6 and a 3, or a 3 and a 6. And when I do 6 over 3, that becomes a ratio of 2 to 1. So my scale factor between them is 2 to 1. But because I'm finding volume, I'm going to have to cube that scale factor. So that's going to become 8 to 1. And then when I set up a proportion, where does the 1600 go? You'd be like, well, that's a big number. It's got to go with the 8. But it doesn't. Because it's going with the smaller radius, the 1600 is actually going to go on the bottom of this proportion. So I'm going to take 8 times 1600 to figure out the volume of the big cylinder. And that becomes 12,800, I should say feet cubed instead of units cubed. So this should be actually feet cubed. Look at that. Looks just like feet now. Actually, I think it almost looks worse. All right. Okay, so these pyramids are similar. Find the surface area scale factor. You're like, Mr. Kenyon, we just did this one. I know the answer, and the answer is 5 to 3. I'm going to tell you right now, no, it is not. I may have you tricked. Maybe you're not tricked. Maybe you know what it is. But I do need to find the scale factor of the side length first, and I can either convert this into cube numbers, or I can just take the cube roots of the numbers, which is fine to do that. So the cube of 1,000 is 10, and the cube of 216 is 6. And that gets me, I should go this way. Oh, I can't go that way. Can I go this way? Ooh, I can. Gets us that 5 to 3, and you're like, oh, Mr. Kane, I told you it was 5 to 3. Yes, you might have said that, but we are looking for the surface area scale factor. So if we're going to convert a volume to a surface area, or a surface area to a volume, we need to go back to the original scale factor. And then in this case, because we're going to area, I'm going to have to square my scale factor. So this can be 5 squared over 3 squared, and 5 squared is 25, and 3 squared is 9. So the surface area scale factor is 25 to 9. So I'm wondering, did I trick you on that? Were you going just straight up 5 to 3? Or did you recognize that you had to go to area, and it's 25 to 9? All right, so here we go. We've got 2 assignments for the second part of this. So these are review, the EP ones, the fun ones, I know. And because this is a similarity assignment, I thought it'd be kind of nice to show you 4 similar pictures of similar people. You know, you've got these 2 people here, and these 2 here that are all similar, and then these 2 that are similar, and then these 2 amazing people here. Obviously similar. You might even think that's the same picture. You're like, oh, that's not even a different person, Mr. Kenyon. But believe it or not, it is. That is a different person. We're just similarly awesome. But for Monday, I want you to do questions 42 through 49 on page EP23. Hold on to that assignment. Then on Tuesday, do questions 50 through 52, and then send them both to me on Tuesday in a new assignment. You might be like, wow, that's not that many problems. Yeah, maybe in physical number, that's not a lot of problems, but I think once you take a look at them, you'll be like, you know what? I think Mr. Kenyon picked a good, challenging assignment. So I hope you found this presentation helpful. Thanks.